Lesson 32 is on probability. Problem number 1 says if a postage for an envelope costs 39 cents for the first ounce and 24 cents for each additional ounce, then what is the postage for a 12-ounce envelope? So if it's 12 ounces, that means 1 ounce costs 39 cents. And then 11 ounces costs 24 cents each. Wow, writing's tough right now. So what we need to figure out is how much 11 ounces of 24 cents each costs. And we're going to do that by multiplying 24 cents and 11. So 4 times 1 is 4. 1 times 2 is 2. 10 times 4 is 40. 1 times 2 is 2. And then we have 2 decimal points. So it's 264. So we have 39 cents on top of the 264 from the 11 additional ounces. So we take 264 plus 39 cents. So we have 13, 10, and 3, and we bring the decimal point down. So it is $3.03. An author writes an average of 8 pages per day. At this rate, how long would it take to write a 384-page book? So we have 1 day per 8 pages. And then we're going to multiply 384 on top over 1. So I have 384 pages. The pages cancel, and what this shows is that I'm going to take 384 and divide it by 8. So over here, 384 divided by 8. 8 goes into 38 4 times. 4 times 8 is 32. 38 minus 32 is 6. Bring down the 4. 8 goes into 64 8 times. So it will take 48, and then my units are the ones that I didn't cross off, so days. Pete saw that he was 200 yards from shore when he dove out of the boat. It took him 49 seconds to swim the first 50 yards. At this rate, how much longer will it take him to reach the shore? So he's already swam 50 of the 200 yards. So 200 minus 50 means he has 150 yards left. And it takes him 49 seconds per 50 yards. So he needs to go 150 yards, so I'm going to put that on the top of the next fraction. So what this shows is I'm going to take 49 times 150 and then divide it by 50. Or I can take 150 and divide it by 50 first, because that's easy to do in my head. So this part right here is 3. 150 is divided by 3, or divided by 50 is 3. So 49 times 3. Well, 49 times 3, 50 times 3 would be 150, and then it's going to be 3 less than that, so 147 seconds. Alonzo chose a name from a box, read the name, then replaced it and mixed the names. He repeated this experiment several times. Out of the 20 names he chose, 12 were 8th graders. What is the experimental probability of choosing the name of an 8th grader based on Alonzo's experiments? So to find experimental probability, all you do is you take the number of favorable outcomes out of the total number of trials. So if we're trying to get 8th graders chosen, he chose 12 out of 20 total trials. So the experimental probability is 12 out of 20. And remember, we always reduce for probability. Both of those can be divided by 4. So 12 divided by 4 is 3, and 20 divided by 4 is 5. So the experimental probability is 3/5. If half of the names in the box are 8th graders, what is the theoretical probability of choosing the name of an 8th grader? Well, what they're telling you is that the probability is just that. Half of the names are 8th graders. So 1 out of every 2 names is an 8th grader. So the theoretical probability is the number of favorable outcomes out of the possible outcomes. So 1/2. There are 18 marbles in Molly's bag. 2 of the marbles are yellow. So 2 yellow. If Molly chooses 1 marble at random, find the theoretical probability that she will choose a yellow marble. So the probability that she will get yellow is the number of possible ways to get what you want, which in this case is yellow. So the number of favorable outcomes is 2, because there are 2 yellow marbles in the bag. And then out of the total number of possibilities, total number of outcomes is 18 total marbles. And we can divide both top and bottom by 2. So the probability of getting a yellow is 1/9. What is the probability that she will not choose a marble? We could do this 2 different ways. We could say, well, if there's 2 that are yellow out of 18 total, that means that there are 16 that are not. And so we could do 16 out of 18 and then reduce it. Or we could recognize that choosing a yellow marble and not choosing a yellow marble are what's called complements. And complements make up 1 whole. So if this is 1/9 here, then to get up to 1 whole, it would be 8/9 more. So the probability that I get not yellow using complement is 1 minus the probability of yellow, which is 1 minus 1/9, and 1 we would rewrite as 9/9. 9/9 minus 1/9 is 8/9. Again, the other way that we could have done that is to say there are 16 not yellows out of 18 total. So divide top and bottom by 2. 16 divided by 2 is 8. 18 divided by 2 is 9. So again, you end up with 8/9. Whichever way makes most sense to you, go with that. Use the figure at right to answer A and B. What is the area of this triangle? Well, to figure out the area, we need to know the height, which is this side right here. I'm going to call it B because it's one of the legs, so it's either A or B. And to figure that out, we need to use the Pythagorean theorem. And the Pythagorean theorem says a squared plus b squared equals c squared. So this will be A, this will be C, and then the one that we don't know will be B. So that turns into, if we put the numbers in, 6 squared plus b squared equals 10 squared. So 6 squared is 36. Plus b squared is 100. So what number, when I add it to 36, gives me 100? Well, 64. So that tells me that b squared has to be 64. And what number, when I square it, is 64? That's 8. So b must be 8. So now that I have that, I can do area of a triangle is 1/2 the base, which is 6, times the height, which is 8. Half of 6 is 3. 3 times 8 is 24. And if we're talking area, it's the units given squared. What is the perimeter of this triangle? We add up all the sides. So 8 plus 6 plus 10. 8 plus 6 is 14 plus 10 is 24. And perimeter is just the units given, meters. Estimate means to round those numbers. So 600 or 610 I would round to 600. 195 I would round to 200. And 398 I would round to 400. 600 plus 200 I do first, which is 800 over 400. And 800 divided by 400 is 2. All right, in number 8, we have order of operations along with multiplying fractions and multiplying and adding fractions. So by order of operations, the multiplication comes first. So I'm going to do 1/3 times 4/5. So 1 times 4 is 4. 3 times 5 is 15. And now to subtract those fractions, I need to have them have the same denominator. And 5 can turn into a fraction over 15. So to go from 5 to 15, I multiply by 3. I got to do the same to the top. 1 times 3 is 3. So I replace 1/5 with 3/15 since they are equal. So 3 minus 4 is -1, and then the 15 stays the same. So the answer to number 8 is -1/15. In number 9, again, we're doing order of operations with fractions. So division comes before subtraction. So I'm going to do this first. When I divide a fraction, I multiply by its reciprocal. So I'm going to have 1/3 instead of divided by 3/4, I'm going to have times 4/3. So we flip over that second fraction and then we turn it to multiplication. So then multiplication still comes before subtraction. So I'm going to do that first. I'm going to have 7/9 minus 1 times 4 is 4. 3 times 3 is 9. And conveniently, these have the same denominator now. And then 7 minus 4 is 3. 9 stays the same. And then I can reduce that by dividing by 3 on the top and the bottom to 1/3. In number 10, I need to multiply before I subtract. So I'm going to do this first. And basically, I'm going to be multiplying 31 times 1, which is just going to give me 31. And then I look at how many decimal places did I ignore. I ignored 1, 2 decimal places, so I moved the decimal over 1, 2 spots. So it's now 0.31. So I have 2.05 minus 0.31. Oops. Got to line up the decimals when you're adding or subtracting decimals. 5 minus 1 is 4. And then 10 minus 3 is 7. Bring the decimal down, and 1 minus 0 is 1. In number 11, there's no rule for adding and subtracting things with powers, so we just need to solve for what these are. 7 squared means 7 times 7, which is 49. 6 to the first is just 6. Anything to the 0 power is 1. So 5 to the 0 power is 1. So 49 minus 6 is 43, plus 1 is 44. Simplify and compare. Well, 3 squared is 9, so I have the square root of 9, and then plus 4 squared is 16. So this is the square root of 25, which is 5. And then on this side, we have the square root of 3 squared. Well, that just cancels out, and we get 3. And square root of 4 squared is 4. So the right side is 7. 7 is bigger than 5. And then B, if I have -1 plus 5, inside the absolute value, I do -1 plus 5 first, which gives me 4. Absolute value of 4 is 4. And then I have -1 in absolute values, which is 1, plus 5 in absolute values, which is 5, and that gives me 6. 6 is bigger than 4. This says write 5/9 as a decimal and a percent. Ninths are one of the fractions that you should just know as a decimal. It's pretty easy pattern to pick up on. Whatever the numerator is of the fraction over 9, that's what the repeating decimal is. So 5/9 is 0.555 repeating. And we can prove that if we actually do the division. We would have 9 can't go into 5, so we add a decimal point. 9 goes into 50 5 times. 5 times 9 is 45. And then we'd have 5 left over again, and we'd have 50 again. 5 times 45, and we'd have 5 left over again, so it would just be repeating 5, 5, 5, 5, 5. So as a decimal, we have 0.5 repeating. And as a percent, we would move that decimal place over 2 spots. So we'd go 1, 2. So we'd have 55.555 repeating. Write 60% as a decimal and a reduced fraction. Well, if I'm going to take 60% and turn it into a decimal, I just do the opposite of what I just did. The decimal is here now. So to go back to a decimal, instead of a percent, I move it 2 places to the left, and that would give me 0.60, and I can ignore any zeros after the 6, so it would be 0.6 as my decimal. And that 6 is in the 10th spot, so as a fraction, it would be 6/10, and I could reduce that then by dividing the top and the bottom by 2. 6 divided by 2 is 3, 10 divided by 2 is 5. So as a fraction, it's 3/5. Which form would you find most convenient to use to find 60% of 15? Well, if I was going to use the percent, what I would need to do is figure out what 10% of 15 is, which is $1.50, and then I'd have to multiply $1.50 times 6, which would be $9. So that was kind of confusing and difficult. So if I did it with the decimal point, I'd still have to I'd have to do multiplication with decimal. That's kind of difficult. So if I tried the fraction way, and I said 3/5 times 15, what that would tell me is I can divide 15 by 5, which gives me 3. 5 divided by 5 gives me 1, and then we have 3 times 3 is 9. Well, that's a lot easier than the other routes. So I'd use the fraction. because it is easy to compute 15 divided by 5 times 3 mentally. Alright. These points are vertices of a rectangle. 3, -5, 7, -5, 7, 2. Plot these points and locate the fourth vertex, then find the area and perimeter of the rectangle. So if I have x and y, remember that these are x and y, so 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so 3, -5 means go to the right 3 and then down 5. 1, 2, 3, 4, 5. Right about there. 7, -5 means go to the right 7 and down -5. 7, 2 means to the right 7 and up 2. So if I was to draw out where this corner should be, it should be right here at the point 3, 2. And if I fill this in, I have 1, 2, 3, 4 as my side length there, and I have 1, 2, 3, 4, 5, 6, 7 as my side length on this side. So if I want to find the area, I need to multiply those two. And I don't know what the units are, so we just call them units, and area is always squared. And then for perimeter, I add them up. 7 plus 4 is 7 plus 7 is 14, plus 4 is 18, plus 4 is 22. And then, whoops, not meters, units, since I don't know what they are. Expand means to use the distributive property and multiply the 3 through. You keep what's in between, so I do 3 times x, and then plus 3 times 12. 3 times x we just write as 3x. 3 times 12 is 36. Now factor means find a factor in the first term and the second term here that's common. Just like in this, when we expanded it, we had 3 and 3 here. So what can we pull out that's common so that we could get back to this point with a number outside parentheses? Well, since we have x squared and x squared we could write as x times x. And then I could write 6x as x times 6. And then I have an x being multiplied by each of those things. Well, that x then could be put out front parentheses like that 3 was in A, and then whatever's left over. So once I get rid of my x's in front, I have x plus 6 left over. Write 6.02 times 10 to the 10th in standard notation. So 6.02 times 10 to the 10th means I'm going to take this decimal point and move it to the right 10 places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Anything that has a bump but no number above it gets a 0. So it looks like it will be 60,200,000,000. Simplify when I have power in parentheses raised to another power. You multiply the two powers. So this is m to the 4 times 3, which looks like m to the 12th. And then when I'm multiplying two things of the same base with exponents, I have r squared times r to the 5th. I add the exponents. R to the 2 plus 5 is r to the 7th. And then when I'm dividing or have a fraction of things with exponents, I subtract them. So I'm going to have 7 minus 3. 7 minus 3 is 4. On a number line, graph the points 2 and 6, then graph the mean of 6. 2 and 6, excuse me. So a number line, and I have 0, 1, 2, 3, 4, 5, 6. So if I'm going to graph 2, put a dot right there on the 2 spot and a dot on the 6 spot. And if I find the mean of 2 and 6, 2 plus 6 is 8. And then divide them by 2, since there's two numbers, is 4. So then the mean is 4. So if you can see, it's exactly in the middle of the 2 and the 6. So in the next one, when it asks us to graph the points -5 and 1, 1, 2, 3, 4, 5, 1, 2, 3. So 5, -5. So -5 is here, 1 is here, and it says use the number line to predict the mean of -5 and 1. Well, before, it was right in the middle of the two numbers, so if I look for the number that's right in the middle, it would be right here, because this is 1, 2 spots away, and 1, 2 spots away from 5. So it looks like the mean will be -2. And that makes sense, because if I take -5 plus 1, I get -4. And if I divide -4 by 2, I get -2. What numbers are members of both the set of whole numbers and the set of integers? Well, whole numbers is 0 and the positive numbers. And integers are positive, negative, and 0. So the only thing that integers adds on of whole numbers is negative numbers. So whole numbers are members of both integers and whole numbers. Rearrange the addends in this addition problem to make the calculation easier, then simplify. Well, when I see 23, I think if I had a 7 to add onto it, that would work out well, because it would end in a 0 then. So 23 plus 7 would give me 30. So I want to do that first, and I can do that by shifting the parentheses to say 23 plus 7, do that first, since parentheses come first, and then add on 18. And that's called the associative property. (23 plus 7 is 30, and then 30 plus 18 is 48. Find the factors of 2100 using a factor tree. Then write the prime factorization of 2100 using exponents. Now if I have 2100, I can have it be 21 times 100, because 21 times 1 would be 21, and I'd add 2 zeros after it. Factors of 21 are 3 and 7. Both of those are prime. Factors of 100, I can do 2 and 50. And then factors of 50 are 25 and 10. Factors of 25 are 5 and 5. And factors of 10 are 2 and 5. Just double checking here. 1 second. Oh, what am I doing? Silly me. 2 and 25. That's what it is. Sorry, guys. 2 and 50. And then factors of 50 are 2 and 25. And factors of 25 are 5 and 5. So I have 2 times 2 times 3 times 5 times 5 times 7 as my prime factorization, and then it wants me to write it with exponents. Well, I have 2 2's, so that's 2 squared. I have 1 3, 2 5's, so 5 squared, and 1 7. Sorry about that little hiccup there. Was able to find the problem though. A spinner shown is spun twice. What is the sample space of the experiment? What is the probability of spinning at least once? So the sample space means what are all the possible ways to spin the spinner twice. One way to do that is to make yourself a table. So my first spin, and then my second spin. I'm going to rearrange that. It makes more sense for the second spin to be on the left to me. Doesn't matter, it's your choice for... So I can either get A, B, or C on my first, and then A, B, or C on my second. Okay, so my sample space then would be if I spun an A first and an A second, or an A first and a B second, or an A first and a C second. A B first and an A second, a B first and a B second, a B first and a C second, a C first and an A second, a C first and a B second, or a C first and a C second. So then if I write my sample space with the squiggly brackets like they do, I can get AA, AB, AC, BA, BB, BC, CA, CB, or CC. That's my sample space. And then what's the probability of spinning A at least once? Well, first of all, how many of these? I'm going to underline the ones that have A at least once. Twice is at least once. Once, 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 once. I think that's it. So probability of at least once, A at least once, is how many favorable outcomes are there? Those are the underlined ones. 1, 2, 3, 4, 5. Out of the total number of outcomes, that's how many are in the sample space. 1, 2, 3, 4, 5, 6, 7, 8, 9 total. So the probability of getting A at least once is 5/9. John and Meg play a game with the spinner. They take turns spinning the spinner twice. John earns a point if a player spins at least one A in a turn. Meg earns a point if a player spins doubles, AA, BB, or CC. Predict who you think will win more often if they played several times. Well, if we look at Meg's probability of winning, she has a probability of earning a point 3 out of the 9 total, because there are 3 doubles and there are 9 total ways to spin the spinner. So Meg probability of point is 3/9. But we already calculated John's probability of a point was 5/9. So John will most likely win more often because he has a greater probability of scoring a point. He has a 5/9 probability, and Meg only has a 3/9 probability. Order these numbers from least to greatest. Well, the most negative one is negative 5.4. And the next negative one is negative 3.2. Then we have 0. And then the next most positive one is 2.3. And then the last one was 4.5. When a page of print is viewed in a mirror, the words appear to be printed backwards. The image in the mirror is an example of which type of transformation? Well, this is a pretty common term in everyday language. It's a reflection. You look at your reflection in the mirror. It's the same thing in math. It's a reflection. Solve by inspection. So if I look at this, what number plus 20 would give me 80? Well, 60 plus 20 would give me 80. So then 3x has to equal 60. So now the question is, what number, when I multiply it by 3, gives me 60? Well, 20 times 3 gives me 60. So we can double check and say 3 times 20 equals 60. 60 plus 20 equals 80. That one works. Find the square root of b squared minus 4ac when a is 2, b is 5, and c is 2. So I do the stuff under the square root first because it's like there's parentheses around it. And I do the squared first. So the 5 squared is 25. And then I have to do the multiplication next. 4 times 2 is 8 times 2 is 16. Then I do the subtraction next, because it's as if there's parentheses around it. 25 minus 16 is 9, and the square root of 9 is 3. The kinetic energy of an object is given by the equation E equals 1/2 mv squared. Find E when m equals 2 and v equals 3. So 1/2 m is 2, v is 3. 1/2 of 2 is 1, and 3 squared is 9. Triangle, this should say, this shouldn't be here. Triangle WXY is isosceles. If angle W is 40, then what is the measure of the following angles? Well, if it's 40, then X and Y are going to be equal because it's isosceles and their sides are equal. Then we have 180 total degrees in the triangle minus the 40 of W leaves us 140 between X and Y. And they're equal, so I can divide 140 by 2. And that gives me 70 degrees for both these angles here. And then, since this line here is 180 degrees, this much is 70, that says that this must be 180 degrees minus 70, which is 110 degrees. So angle X is 70 degrees. WYX, so that's this angle, is 70 degrees. And then WYZ is this angle, which we calculated as 110 degrees.